What's up? It's Mr. Wicklehouse, and today we're talking about angles of triangles and isosceles triangles, stuff like that. Okay, the first thing is probably something, or I hope it's something that you might know already. It's called the angle sum theorem. What the angle sum theorem says is that the sum of the measures of the angles of a triangle is equal to 180 degrees. Okay, that means that all three of these angles, when you add them all up, is equal to 180 degrees. Now let's talk about how we can use that. So let's look at a couple examples. Let's look at example A first of all. Okay, so they want me to find the missing angle measures. So in other words, I need to find angle A, or angle 1 and angle 2. Well, to do that, oh, and angle 3 down here, sorry. So I'm looking for three angles. So angle 1, angle 2, and angle 3. Well, angle 1, I know that this is a triangle, so 43 plus 74 plus angle 1 is equal to 180 degrees. Okay, so if I add these two together, you get 717 plus angle 1 equals 180. Then I'm going to subtract 117, which then gives me, let's see, 63. That means angle 1 is 63 degrees. Okay. So if angle 1 is 63 degrees, and I see that these two lines intersect each other, that means angle 1 and angle 2 are what kind of angles? That is correct. They are vertical angles. Let me get this back into focus because it just likes to go out of focus on me all the time. That's not much better. Hold on. Here we go. It's a little better. So they're vertical angles, angle 1 and angle 2, which means then that angle 1 and angle 2 are congruent or equal to one another. So that means angle 2 is 63 degrees as well. Well, if angle 2 is 63 degrees, and I'm looking for angle 3 now, then I know that 63 plus 79 plus angle 3 is equal to 180 degrees. 63 plus 79, let's see, that's 2, carry the 1, 142. Plus angle 3 equals 180. Subtract 142. That's going to be 38. So angle 3 is equal to 38 degrees. So that's kind of the idea of what we're doing here. Okay. Let's look at this second example. I'm looking for angle 1, 2, 3, and 4. Oh, my goodness, that's a lot of angles. So, I'm looking at this. I've got two unknown angles here in this triangle, so I can't really use that one. I've got two known in this one, and then angle 2. So I'm going to find angle 2 first. 50 plus 70 is 120. 120 minus 180 is going to be 60 degrees, which means angle 1 is also 60 degrees because 1 and 2 are vertical angles. If angle 1 is 60 degrees, then 60 plus 65, that's 125, which means angle 3 is 55 degrees because 125 minus 1, or 180 minus 125 is 55. Alright. Well, now you might be saying, well, Mr. Wicklehouse, how am I going to find angle 4? Well, if I have four angles together like this, and they're vertical angles, I can think about this as being like a circle. And how many degrees are in a circle? right? 360. Well, angle 1 and angle 2 are both 60. So if I take 360 minus 120, then that's going to give me 240. And I know angle 4 and this angle are equal to one another because they're vertical angles. So that means I can take this and divide it by 2. So angle 4 is going to be equal to 120 degrees. Okay? Alright. Now, that's how we mess around with those guys. Let's move on a little bit. So here's another theorem that we're just going to kind of mention in passing. You won't use it very often, but it could pop up here and there. Okay? So it says if two angles of one triangle are congruent, then, or are congruent to two angles of a second triangle, then the third angles of the triangles are also congruent. In other words, angle A here is congruent to angle D, angle B here is congruent to angle F. Well, that means that angle C is congruent to angle E. Okay? Because these two are congruent to these two, so by definition or by this theorem, this third one is congruent, okay, or equal to one another. Alright, moving on. Let's talk about the exterior angle theorem. Exterior angle is formed by one side of a triangle and the extension of another side. So like this one down here, here's one side of the triangle. I extend out this other side and I make this exterior angle right there. Okay? So this is the exterior angle. Remote interior angles are the angles of a triangle that are not adjacent to a given exterior angle. In other words, the remote interior angles for this exterior angle are these two, right here and right here, X and Y are the remote interior angles. Okay? They're not adjacent to this exterior angle, so they're the remote interior angles. Now that we've cleared up those couple definitions, we can say that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So if I take these two remote interior angles and add them together, I'm going to get the measure of this angle. Okay? Alright. Let's look at a couple examples of how to find that, how to use this rather. Okay. So, they give me angle B, and they give me this exterior angle C right here. I know that B is 20, and I know that C is 56, and they want me to find the measure of angle A. So what's that? What is the measure of that? Well, I know that angle A plus angle B equals angle BCD, or this exterior angle. Okay, so angle A plus 20 equals 56. If I subtract 20, then I get 36. The measure of angle A is 36 degrees. Okay? Alright. Let's look at this one. They give me angle A is 55, angle B is 27, and they want me to find angle DCB. So this angle right here, what's that angle? Well, I know angle A plus angle B equals angle DCB. That means 55 plus 27 equals angle DCB. 55 plus 27 is 75, 82 degrees. Okay? That's all there is for that. Just these two remote interior angles are equal to the exterior angle. Alright, moving on. So we've kind of already talked about what an isosceles triangle is. It's a triangle with at least two sides that are congruent. And the angle formed by the congruent sides is called the vertex angle. And the two angles formed by the base and one of the congruent sides are called the base angles. Okay. Now we've got this isosceles triangle theorem. It says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. In other words, if I've got this side A, B, and side BC are congruent to one another, then that means that the side opposite of this side, A, is congruent to the angle opposite of this side, which is C. So angle A is congruent to angle C. So two sides congruent means two base angles are congruent. Okay? Alright, let's use this here. DE is congruent to CD. So DE is congruent to CD. And BC is congruent to AC. I'm just marking up my picture so I know what's congruent. These marks just mean congruency. And I know that angle CDE, this one up here, is 120 degrees. It wants to know what the measure of BAC is. Okay. Well, I know that this is 120 degrees, and I know that that plus angle DCE plus angle DEC is equal to 180 degrees. Okay. But I also know that these two angles right here are congruent to one another. So I could just call these X. So I could have 120 plus X. And since this is congruent to that one, then I could call that one X and equal to 180. So then 120 plus 2X equals 180. Subtract 120 from both sides, I get 2x equals 60, and then x equals 30 when I divide by 2. So that means this angle right here is 30, and this angle right here is 30. Okay? Well, if this is 30, then what's this angle right here? Well, these two right here are vertical angles, so that means this angle right here is 30 degrees. Okay, we're almost there, because this is another isosceles triangle, which means that angle B and angle A are congruent to each other, and this is 30, so 30 plus angle B plus angle A equals 180, and then I'll call these Y this time, so 30 plus Y equals 180. Add them together, plus 2y equals 180. Subtract 30, I get 2y equals 150. Divide by 2, I get y equals 75. That means that angle BAC, this angle right here, is 75 degrees. and I found my answer. Okay, so I used this isosceles triangle theorem to use these two angles being congruent in order to find what the measure of the angles were. I used the vertical angles, and then I did the isosceles triangle theorem again to finally get my measure of 75. Okay. Here's another theorem. Sometimes this is called the converse isosceles triangle theorem. And all it says is that two angles of a triangle are congruent, then the sides opposite those angles are congruent. So we've got angle D and angle F that are congruent. So then DE and EF are congruent, and then this is an isosceles triangle. Okay. So right here in this example, it says name all of the congruent angles. Well, I know that angle L is congruent to angle M. Okay, that's one pair because it's right there given to me. These little lines a lot of times will mean congruent when you talk about congruency. Well, what else is congruent? Well, I know that by the isosceles triangle theorem that angle MLN is congruent to angle MNL. Okay, that's all I got for sure. Okay, they tell me that segment ML is congruent to segment MN. And then I also know by this theorem here that because these two are congruent, then PM is congruent to PL. All right. I think that's enough for right now. And we'll meet up later, and I'll see you guys in class.